Hello everyone and welcome back to our channel mootechie. A special welcome to all the dairy technologists and students joining us for this second class in Unit 4. In our last session, we covered the fundamentals of filling equipment. Today we will focus on the next critical step, the closing equipment used to seal the packages. We are now moving on to the topic of closing equipment. This is the machinery that securely seals the package after it has been filled. The methods used for closing packages depend on several factors. These include the type of packaging material, the specific food product inside the package, the processing and storage conditions it will face, the type of packaging equipment available, and the strength of closure required. Closure methods vary significantly based on the packaging material. For glass containers, metallic or plastic caps are used. Metal containers are closed by double seaming the ends onto the can body. Laminates are typically sealed using heat. Paper and cardboard packages are closed with adhesives or by sewing. For complex packages that combine materials, such as those with glass or metal plus paper and plastic laminated aluminum, a combination of heat sealing and capping might be used. Let's first look at glass bottles. The manufacture of glass bottles involves two primary methods: the press and blow process, often used for jars, and the blow and blow process, typically used for bottles. In the press and blow process, a gob of molten glass is first dropped into a blank mold. A plunger then presses down to form the initial blank shape. This pressed blank is then transferred to a blow mold, where air is blown in to create the final jar shape before it is ejected as a finished jar. The blow and blow process also starts with a gob dropped into a blank mold. In this method, the neck is formed first. The blank is then blown into shape within the mold. This blank is transferred to a blow mold, where it is blown again into its final bottle shape and ejected. For sealing these glass containers, various closure materials are available. These include standard metallic caps, aluminum roll-on, pilfer-proof caps known as ROPP caps, ring pull caps, the classic crown cork, and various types of plastic caps. The application of these closures is specific. Metallic closures are used for jars with wide openings and threaded necks. For a better tightness, they often include a plastic seal made from natural or synthetic rubber, or an aluminum sheet sealed onto the mouth of the container. Crown corks provide a good sealing effect, especially important for carbonated drinks. Aluminum ROPP caps are used on one-way bottles with threaded necks and feature a tamper evidence ring for consumer safety. This slide shows an image of a capping machine. Another image illustrates the feeding and capping process for glass bottles. A common type of equipment is the Rotary Monoblock carousel. This machine performs both filling and closing in one integrated unit. It can have a high capacity such as 12,000 bottles per hour. It can handle bottles of all sizes, with adjustments made at the inlet and outlet star wheels to accommodate different dimensions. This slide shows an image of a rotary monoblock carousel equipment. For closing plastic containers, there are different machine types. These include rotary screw capping machines and linear screw capping machines. They can also be classified as multi-head screw capping machines for high-speed or single-head machines for simpler applications. Capping machines for items like cups are synchronized with the filling machine. They often use a punched aluminum foil seal. This foil is very thin, typically 0.04 to 0.05 micrometers thick, and a common diameter is 38 millimeters. This slide shows an image of a rotary cup sealing machine. Now let's discuss metallic containers, specifically cans. There are two main types: the two-piece can and the three-piece can. Two-piece cans are manufactured by either the drawn and iron process or the drawn and redrawn process. These processes involve drawing a metal cup from a sheet and then ironing it to thin the walls and increase the height, or redrawing it to a smaller diameter, often resulting in a dome-shaped base. The fabrication of a traditional three-piece soldered can starts with a body blank that is notched at the corner. The blank is then hooked, meaning the edges are bent to form hooks. The body is formed into a cylinder, and the side seam is soldered together. End pieces are prepared separately. The primary method for closing metal cans is double seaming. First, the can rim is flanged outwards. Then, the end is applied. The end has a lining compound that will form the seal. The can and end are positioned for crimping, where the flange and the end curl are rolled together to form a tight hermetic double seam. The components of a double seam include the seam thickness, the seam gap, the overtab, and the pressure ridge. It also involves the body hook length, the counterhook depth, and the thicknesses of the body and end plates. This slide shows an image of a drum seaming machine used for larger containers. Carousel seaming machines are used for high-speed can closing. During this process, steam is often blown through jets onto the surface of the can contents just before sealing. This steam expels air, and after it condenses, creates a vacuum in the headspace, which contributes to the can's tightness and preservation. For closing plastic packages, heat sealing is the common method. This is done using electrically heated bars or plates. The temperature used depends on the plastic material. For inline pouch forming, it's around 155 to 160 degrees Celsius. For polyethylene, 110 to 120 degrees Celsius. And for polypropylene, around 130 degrees Celsius. For plastic cups, a laminated top film is used for sealing just after filling. This film is heat sealed automatically by special bars, and a machine can seal many cups, for example, 84 cups, in a single strike. Airtight aluminum covers are also used. These are laminated for effective sealing and increased stability. These covers can also be crimped mechanically over the edge of the container. Plastic bags are often sealed using vacuum sealing. The bag containing the product is placed in a chamber, the air is evacuated, and then the bag is sealed automatically. The heating seal heads have Teflon strips to prevent the plastic from sticking to them. The pressure applied during sealing is typically around 4 bars. Cardboard boxes are sealed using adhesive kraft paper or with plastic tapes that are coated with adhesive. Cartons like those used for milk are typically closed either by heat sealing the flaps or by using glue. Thank you for joining this class on closing equipment. We've explored the various methods and machines used to seal everything from glass bottles and metal cans to plastic pouches and cartons, ensuring our dairy products are protected until they reach the consumer. This knowledge is key to completing the packaging process. Thank you. See you in the next class.